The first thing I did, walking up to the system, was I documented the current state of the motor, how it responded to controls, etc., as well as things like the power cable, power switch, and the e-stop. Next, I powered everything off. I then opened up the VFD and noted that it only had two digital inputs total, and that both were from the selector switch, one being forward and the other one being reverse. Then I opened up the control cabinet and took note of how things were wired. Since we were only concerned with the selector switch, the only thing I had to figure out was which digital input was forward and which was reverse. This was easily accomplished with a few continuity tests, showing that green was reverse and yellow was forward. From there, I powered up the system and then proceeded to document all the current parameters on the VFD into my notebook. Next, I started diving into the documentation for this device. After a while of reading, researching, and taking notes on the endless parameters and basic controls of this device, I became familiar with its controls and the functionality, and then came up with a solution for the assignment. Looking back into the documentation, we first need to note that we can set specific speeds to specific parameters, then call them by activating the specific combination of bits. In this case, we'll be using parameter 5.01 and parameter 5.02, which is bit 1 and bit 2. Next, we need to note that P301 needs to be set to 0 so that digital input 1 will control the forward direction and digital input 2 will control the reverse. Since it is default, we don't actually need to change anything here. Next, we need to note that digital input 4, parameter 303, is set to bit 1, and digital input 5, P304, is set to bit 2. Please note that with this method, we have one wire telling the VFD the direction, and one the speed, for both forward and reverse on the selector switch. To make it so that the selector switch could send a signal to two digital inputs at once, I used two jumper cables so that I could connect digital input 1 to digital input 5 and digital input 2 to digital input 4. Now all we have to do is set the individual speeds back in P501 and P502. The speed that we are entering is in hertz, and the way we determined what hertz to use was by using the equation as shown, all found in the documentation. Here is the system working. First, we have to hit the forward position on the selector switch, then hit the start button. As you can see, the motor starts to ramp up to about 905. To verify the RPM, we're going to use a tachometer. This tachometer is a little finicky, so you have to hold it just right in order to get consistent results. As you can see, we're getting about 942, 934-ish, which is just within our plus or minus 50 tolerance. Now we're going to switch to neutral and let the motor ramp down. Once it has stopped, we're going to hit reverse, and then again verify the RPM with the tachometer. As you can see, it's about 438, 447, which is just within our tolerance.